Hello and welcome to lesson 3.1, Lines and Angles. Our objective in this lesson is to identify parallel, perpendicular, and skew lines. We'll learn what those words mean in just a moment. And identify the angles formed by two lines and a transversal. Again, we'll talk about all these new terms in this lesson. It'd be a really good idea, before you begin watching this video and taking notes, to turn to page 146 in your textbook and copy down all the vocabulary for lesson 1 in your note packet so that that part is already done. You don't have to pause the video continually. We can just get through the video a little bit more quickly. So again, if you have not filled out vocabulary using your textbook, go ahead and do that now before watching the rest of the video. Alright, now if you are done with the vocab, we can go ahead and try a little warm-up to begin. Each of these sentences or phrases is best identified as a vocab term that we have learned in previous chapters. So go ahead and try and find the best matching vocab term for each one of these. Alright, if you need any more time, pause the video. Otherwise, let's take a look at our answers. Points that lie in the same plane, we understand those are coplanar. Two angles whose sum is 180 degrees are supplementary angles. The intersection of two distinct intersecting lines is a point. Remember, two points intersected exactly, or two lines rather, intersected exactly one point. And then a pair of adjacent angles whose non-common sides are opposite rays form a linear pair. Alright, let's go ahead and take a look at the vocab terms that you will need to understand in this lesson. Again, these are things that will appear in your textbook, and there are places for them throughout the note packet in Chapter 3, Lesson 1. Hopefully you've had a chance to already write those in. We'll talk about parallel lines, perpendicular lines, skew lines, parallel planes, a transversal, corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. We will talk about all these terms throughout the remainder of this video. Here's the first four terms. Parallel lines are coplanar and do not intersect. In this figure, AB and EF are parallel. They have been marked with these symbols in the diagram, and then the symbol that we use for parallel in our label are these two vertical lines side by side. So also EG and FH are parallel lines marked with these same kind of symbols. We would call these symbols chevrons or carets. Perpendicular lines intersect at 90-degree angles, and we use this symbol to label them as perpendicular, a little upside down capital T. In the diagram, we mark them as right angles, and that shows that the lines are perpendicular. So AE and AB are perpendicular. EG and GH are also perpendicular, marked by these right angle symbols. We also need to understand what skew lines are. Skew lines are not coplanar, meaning they are not along the same plane, and they are not parallel, and they do not intersect in any way. So skew lines are lines that are completely non-coplanar and will never intersect, so they're not parallel either. So we have lines such as AB and EG. These will never intersect because they're not on the same plane, but they're also not parallel. Now there would be many other pairs of skew lines listed. This is just one example. Parallel planes are planes that do not intersect. In this figure, plane ABE, which is the top part of this box, would be considered parallel to plane CDG. C should be a D here. The diagram shows the letter W, but we can replace that with a D. CDG, the bottom of the box, is parallel to plane ABE. Let's try example 1. Let's use the diagram to identify each of the following. First, we need to identify a pair of parallel segments. So let's look at a pair of segments that would be parallel. Well, these markings show we have parallel segments. This diagram is created by these cards, these playing cards that have been stacked together. But in the diagram, segment LM and segment KM are marked as parallel. We also have the vertical sides of this box that are also marked as all four being parallel, so we can take our choice. Again, if you look at the bottom of the box, these are also parallel. So we could say LM is parallel to KN, like this. Segment LM is parallel to segment KN. Written just like that. Next, we're asked to identify a pair of skew segments. Segments that are non-coplanar and do not intersect could be segments such as LM and KP. There is no symbol to show that they are skew, so we just write them like this with the word and, or you could replace the word and with a comma. Next, a pair of perpendicular segments. Remember, perpendicular segments are marked as right angles. So we have a right angle symbol here and a right angle symbol here and here at the corners at R. So we can take our pick of any one of these right angles to pick a pair of perpendicular segments. Let's start with the first one I circled. We can say that segment NS is perpendicular to segment RS. Lastly, let's find a pair of parallel planes. Planes, remember, are those flat surfaces extending in all directions in 2 dimensions. So each card could be thought of as a plane. So we just need to pick one plane and a plane that is parallel to that. Well, we have the top and bottom cards with parallel sides here, so we can say the planes are parallel. So we could call one plane the top card. We could call it plane KLM or LMN or NKL. Picking any 3 letters is fine. So we'll say KLM is parallel to plane PQR. Why don't you take a few moments and identify parallel segments, skew segments, perpendicular segments, and parallel planes using this diagram. Same thing we just did using a different diagram. Why don't you take a few moments and answer these parts in your notes. Alright, you might have gotten answers something like this. I chose line segments CD and BE as my parallel segments. FG and DH for skew segments. Those will never intersect, but they're also not parallel. And BF is perpendicular to FJ. That's the only right angle that we are given, so that's what we should assume are the perpendicular segments. And then I chose the top and bottom of the box again for my parallel planes. FGH is parallel to BCD. All right. We have some other terminology that deals with the idea of what is called a transversal. Okay, remember, a transversal is a line that intersects 2 coplanar lines at 2 different points. This transversal T and the 2 other lines, R and S, form 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. Those 8 angles are going to be related as possible pairs of angles written out here. In this example, corresponding angles are angles that lie on the same side of the transversal and on the same sides of lines R and S respectively. So they tell you that angles 1 and 5 are corresponding angles. Angle 1 is to the left of the transversal and above line R. Angle 5 is also to the left of the transversal and it is above line S. Those are in corresponding positions. So we could say 3 and 7 are corresponding angles. 4 and 8 are corresponding angles, and 2 and 6 are also corresponding angles. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal T, between lines R and S. So alternate carries with it that meaning of opposite. Interior means between the 2 non-transversal lines. So we say that 3 and 6 are alternate interior. We could also say 4 and 5 are alternate interior. Then alternate exterior angles lie on opposite sides of the transversal T outside lines R and S. So they give us the examples of 1 and 8. Those are alternate sides of the transversal, but they are in the exterior of those two lines. They're outside. Angles 2 and 7 would also be alternate exterior angles. Same side interior angles, or consecutive interior angles, lie on the same side of the transversal between lines R and S. So 3 and 5 are on the same side of the transversal, and they are between the two lines. 4 and 6 would also be same side interior angles. So in this example, we will identify the different angle pairs that are requested here and give an example of each one. This is our transversal, so I'm going to go ahead and mark this as T. Since they don't give me a name for this line, I'm just going to mark it as T. And then I can call this line R, this line S. Those letters are just chosen randomly, but we use T because it's transversal. So we want a pair of corresponding angles. Remember, corresponding angles are on the same side of the transversal, either the left or the right here, and they are going to be either above or below their respective line R or S. Well, let's say I started with angle 1. It is to the left of the transversal, and it is above line R. So the corresponding angle would be to the left of the transversal above line S. That'd be angle 5. So angle 1 and angle 5 are corresponding angles. They're not the only ones we could choose, they're just the two that I chose. Alternate interior angles, they're in the interior between lines R and S, so we're choosing from 3, 4, 5, and 6. And they're on opposite sides of the transversal. So if I chose angle 3, the alternate interior angle to angle 3 would be angle 5. Alternate exterior angles could be angle 1 and then angle 7, because those are on opposite sides of the transversal, but they are outside of R and S. Same side interior angles could be angles 4 and 5 or 3 and 6. I said 4 and 5 first, so we'll use that. And then we throw in the idea of same side exterior angles, which could be like 1 and 8. So why don't you use this example? Here our transversal runs a little more left and right, and our lines R and S a little more up and down. But go ahead and find angle pairs for corresponding angles, alternate interior angles, alternate exterior angles, same side interior, and same side exterior angles. Okay, here are some choices that I made. Corresponding angles, 5 and 7. They're both below the transversal on the left sides of lines R and S. Alternate interior, 2 and 7. Opposite sides of the transversal, but between lines R and S. Alternate exterior, I chose 1 and 8. Alternate sides of the transversal and outside of lines R and S. Same side interior, angles 2 and angle 3. Same side exterior, angle 1 and angle 4. These are only some options from each of these examples that I could have chosen. Okay, in our final example, we are asked to use the diagram to identify the transversal, because I have 3 intersecting lines here. Any one of these could be a transversal, and to classify each angle pair. Before we start doing this, here's a helpful hint to remember. To determine which line is the transversal for a given angle pair, locate the line that connects the vertices of the angles. Okay, what line are both angles using? That's going to be the transversal. So what I would like you to do first is go through this example for A, B, C, and D and just identify which line L, M, or N will be the transversal. Alright, you should have gotten these results. 1 and 3 are both on line L, so that's the transversal. 2 and 6 are both on line N, so that's the transversal. 4 and 6 are both on line M, so that's the transversal. And 2 and 5 are both on line N, again, so that's the transversal. Now we can go through and identify the angle pair for each one. Alternate interior, alternate exterior, corresponding, or same side interior angles. Why don't you take a moment or two and answer these questions. Okay, let's quickly take a look at our answers. 1 and 3 are both on the same side of transversal L, and they're both to the left of the other two lines, so they're corresponding angles.